Hello and welcome back. We're still looking at chapter 3.7 related rates. We're looking at moving ladder. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Here's the example. We're pulling this end of the ladder, and we have 3 questions to answer. I'm going to go over those individually, so don't forget to subscribe. Here's question number A. How fast is the top of the ladder moving down the wall when its base is 7 feet, 15 feet, 24 feet from the wall? So now let's take a look at this problem. Remember, this is where we have a change, and this is 2 feet per second. And basically, this is our change in the x value with respect to time. So that it's already given, as you can see here. I'm going to use a different color to illustrate that. It's here. That's how fast it's moving in that direction, going to the right as I pull one end of the ladder. Now, to answer this question, how fast is the top of the ladder? So how fast is it moving down? As I'm illustrating here in this yellow color. How fast is moving down? And we can see this is related to our y value. Now, because this ladder and the wall create a 90-degree angle, so we can say that Pythagoras theorem it's applicable. So x squared plus y squared is equal to c squared. Where we already know that c squared it's already given. That will be 25 squared. I'm not really worried about the computation. This is more about the process behind how to get this process illustrated. So how fast is the top of the ladder moving down the wall when its base is 7 feet? So its base, we know its base is x, it's 7 feet away. So that is given. Therefore, if they already told us what the distance is from the wall, and as you can see from this picture here, from this side all the way to here, it's 7 feet. So let's try to compute that. Okay, so first of all, we have our formula, which is y squared plus, and then we know that x is already given, is equal to, well, let me go back a little bit. So let's start from the beginning. So y squared plus x squared is equal to 25 squared. Now let's take the derivative of all of this with respect to time. So we need to take the derivative of the left side and right hand side. So this is equal to 2y dy dt plus 2x dx dt, which is equal to 0 because that's a constant. Now that we have our answer here, we can solve for dy dt because that's what the problem is asking us. How fast is the ladder moving down? So moving down is a change in our y value. All right, so now that we know that, we need to move terms around. So if I move 2x dx dt over to the other side, now we can cross out this side, and I'm left up with, I'm going to use this space over here, 2y dy dt is equal to negative 2x dx dt. And then I still need to solve for dy dt. So I need to divide by 2y. I divide by 2y. So this is crossing out. So now I'm left off with, I'm going to use a different color now. So this is dy dt equal to negative 2x. I'm going to do the 2y here, dx dt. And that simply crosses out our 2 here. And we're left off with simply negative xy dx dt. And now that we're ready to plug in the values, once we're here, it's totally up to you, but if you want to calculate this solution, we know that we need to input the values for x and y. So how do we do that? Well, we have our formulas here. So we know already the x value is equal to 7. We also know dxdt, but we need to find out what's the value of y. So x squared plus y squared equal to 25. That doesn't change. It's a fixed value. The ladder doesn't shrink at all. So the y value will be y equal to, and all I'm doing is I'm moving the x squared over the x squared over. So 25 squared minus x squared, and then I'm taking the actual square root. So therefore y is equal to the number up here, as you can see here. Therefore dx dt is equal to the value of x, negative, the value of x is simply 7 over y, which is the square root of, that will be 25 squared minus, and we know the value of x, which is 7, and that will be a square, times 2, which is the 2 feet per second, so 2 over 1, and that's our final solution. Alright, now that we have the solution for letter A, let's move on to letter B. Now consider the triangle formed by the sides of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet. Once again, what we're looking at is a triangle. So what is the area of a triangle? Area of a triangle is equal to base times height over 2. Now, I left intentionally these two values here from our previous part of the example. So just to keep that information available. Now, our base and our height we already know is equal to x and y, right? Over 2. Now that we have that information, let's take the derivative. The derivative of area. Same process. Let me just illustrate that. That way we become familiar with it. So we take the derivative with respect to time of both sides of the equation, the derivative with respect to time, and we are left with dt, change in area over the change in time, and that will be equal to the value of x with respect to that. It's dx dt. Don't forget the 1/2, but I'll put that after. So times y plus, it's a product rule, dy dt times x, and this is all times 1/2. Let me illustrate that. So 1/2 here. I'm going to use square brackets just to illustrate that. So now that we have that information, we're ready to find the solution. So we already have dx dt here and dy dt. That's the reason why I kept that information here in general. Now we need to find the x and y values. Same process as we did before. I'm going to do that up here using a different color to make sure that we illustrate that. So we already know the x value at 7 feet, and of course the hypotenuse is fixed. Therefore we have y squared plus x squared equal to 25 square. We move the x squared over, and we end up with y squared equal to 25 squared minus x squared. And then we take the square root of both sides, and we end up with y equals to the square root of 25 squared. Oops, let me erase that. 25 squared minus x squared. And we know that that's simply y equal to the square root of 25 squared minus 7 squared. Now that we know what the y value is, we already know x, and we're ready to simply plug in. So dA dt is equal to 1/2. We have brackets. Dx dt, we know it's 2/1, which is up here, as I'm illustrating there. So 2 feet. And then times y value. The y value we already know it's simply the square root of 25 square minus 7 square. And we have a plus sign there, dy dx dt. It's also here, as I'm pointing out. So we have parentheses, negative x over y. But because we already have the two values there, and we know that x is 7, and we have over y, which is the square root of 25 square minus 7 square. And this is times x. The x value is simply 7. And this is our final solution. Once again, I'm not worried about the computation. I'm more worried about the process of getting there. All right, let's move on to the next part of the problem. The last piece that we're looking for is letter C. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall. So once again, the angle that we're looking at is here. This is my angle theta. So because I know this is my x and this is my y, I want a trig identity that relates angles in my opposite side and hypotenuse. So if you look at the angle here, if you're not familiar with it, I'll try to post another video, but I can see that that's pretty much what we call let's use yellow, SOHCAHTOA. Right, so this is sine, cosine, and tangent. So if we take the tangent, sine, we know that the angle is equal to sine theta equal to, as you can see, opposite, which is x over hypotenuse. My hypotenuse is fixed, it's at 25, and I'm ready to take the derivative now. So if I take the derivative with respect to time of the left-hand side, I need to take the derivative with respect to 10 of the right-hand side. So the derivative of sine theta is simply cosine theta times the derivative of theta with respect to time is d theta dt, which is equal to 1/25, and then the derivative of x is dx dt. Now if I try to solve for tangent theta in time, I need to divide by cosine theta. So that crosses out my cosine, and I'm left off with d theta, or tangent theta in the angle, over the change in time equals to 1/25 change in x with respect to time times 1 over cosine theta. So I'm ready to plug in all of the numbers to find the solution. So we have, I'm going to illustrate that here, d theta dt is equal to 1 over 25. The change in x is simply 2/1, as you can see here. And that's equal to 1 over cosine. And cosine in our problem of that theta is simply cosine. As you can see here, cosine is adjacent, which is cosine theta is equals y over our hypotenuse, which is 25. Now, if you want to find out what the y value is of this, we can simply say x squared plus y squared equal to 25. Therefore, we subtract x. So y squared equals to 25 minus x squared, which is equal to taking the square root So y is equal to the square root of 25 squared minus x squared. So therefore, cosine here is simply equal to y, which is the square root of 25 squared minus 7 squared, which I'm replacing the x value. Oops, this is not leaving. Illustrating the 2 here. Over. And that's equal 25. So that is our final solution for this problem. Alright guys, don't forget to subscribe if you're liking the content, and I'll see you on the next video. Goodbye now.